Okay, for this fourth order differential equation, if we translate what we have in terms of Laplace transforms, now we have with the initial conditions, so we have x of 0, x prime of 0, and x double prime of 0 are all negligible, but for x triple prime of 0, okay, we have is equal to 1. And if I take the Laplace transform of each of the terms in the equation, so for the Laplace transform of the fourth order derivative of x with respect to t, okay, that is going to be s to the fourth times the Laplace x sub s, and we have minus s cubed x naught minus s squared times x prime naught minus s times x double prime naught, and then we have minus x triple prime naught, and again for x naught, x prime naught, and x double prime naught, those are negligible, and we have x triple prime naught is equal to 1. So you're going to have the first and the last terms, okay, to be non-negligible. So we had the Laplace transform terms to end up as the difference between s to the fourth times the Laplace x sub s minus 1. Now for the next term, we have the Laplace transform of 8 times the second order derivative of x with respect to t. And I can write this as 8 times the Laplace transform of x double prime t. So you're looking at 8 times s squared times the Laplace x sub s minus s times x naught minus x prime naught. And again, both x naught and x prime naught are negligible. And so this becomes 8 times s squared times the Laplace x sub s. Okay, so for 16 times the Laplace transform of x of t, this is equal to 16 times the Laplace x sub s. And for the Laplace transform of 0, again, you would have 0 over s, however 0 is negligible, so that goes to 0. And if we take what we have and rewrite the equation in terms of the Laplace transform terms, so we have this particular setup, and combining what I have with the Laplace transform variable x sub s. So again, we have s to the fourth plus 8s squared plus 16 times the Laplace x sub s, and we can move the constant 1 over, so we have is equal to 1. And so for what we have in the setup, okay, so we have for the Laplace transform x sub s, so we have 1 over, okay, this squared trinomial, so you have s to the fourth plus as squared plus 16, and guess what? So we have x sub s is going to be equal to 1 over, and we have what's going to be s squared plus 4 quantity squared. Okay, so from the Laplace transform table, okay, so we have for 1 over s squared plus 4 quantity squared, okay, and now we had the Laplace transform is going to be the form of the reciprocal of the square of s squared plus k squared. So just kind of taking what we have for x of s, okay, so just to kind of keep things in line here, so you're going to have 1 over s squared, and where the k value is going to be at 2, so you have s squared plus 2 squared quantity squared, and guess what? Okay, so we're going to have for the inverse Laplace transform, so you have with x of t, well guess what? With k at 2, now you're going to have 1 over 2k cubed, so we're looking at 1 over 2 times the cube of 2, and we have times the quantity of the sine of kt, and in this case we have the sine of 2t, and you have minus kt, so it'll be minus 2t. You have the cosine of kt, so you have the cosine of 2t. And looking at what we have and expanding, okay, so we have for x of t. Okay, so 2 cubed is 8 times 2 is 16. And we have for x of t, so we have 1/16 of the sine of 2t, and 1/16 of negative 2t, well, that's going to be negative 1/8 of t times the cosine of 2t, and that will be the final result in this problem.